Hi everyone, Luigi Renzullo here, hoping you're all well. Um, Welcome to week 6 tutorial on radiation and radiative transfer. So in today's tutorial, we're going to look at key aspects to the interaction of solar radiation with the Earth atmosphere system that we couldn't go into any great depth in this lecture on solar radiation. However, all the material I think you need to successfully complete this tutorial can be found in the lecture on solar radiation. Where I felt you might need some extra information, I've tried to include it in the questions here. But if the lectures and what I provide in the questions isn't enough, by all means, do avail yourself of the wonderful resource that is Google. I'm not ashamed to say that I often refer to Google when I need some quick reference advice, like what's the gravitational constant, mean Earth-Sun distance, mean radius of the Earth, for example. So it's a great resource for that stuff, but don't trust everything you see. And so I do suggest that as far as authority goes, my lecture notes, what I have here, and then third, Google. Okay, so today's tutorial has 3 activities: solar radiation, radiative transfer, and atmospheric transmittance. The first activity on solar radiation sort of revolves around, forgive the pun, the Earth's orbit around the sun, particularly what it means for what we observe from the Earth's surface as the Earth makes its journey around the sun. I hope it's no surprise to you that the Earth goes around the sun in an ellipse. And so therefore the Earth-Sun distance will vary because the sun is at one of the foci of the ellipse, not at the center. So you'll think about these questions referring to your lecture notes. Surface areas of spheres, that sort of stuff should be familiar to you. It's how you apply them, I think, might trip you up, but please pay attention to the questions, the wording, and remember your units. The fundamental units of distance, for example, are meters, even though I might express stuff in kilometers. When you're doing the calculations, do remember that we work in meters, we work in joules, and we work in seconds. So that's the first activity. The second activity on radiative transfer, you are placing yourself in the position of an observer and you're watching the sun progress across the sky during the day. And you think about your orientation to the sun and think about its journey, the radiation's journey from the top of the atmosphere to the bottom under various conditions, clear skies, hazy skies. Again, this is stuff where I think most of it is covered in the lectures, but you know, there's some key things like path length that I might not have explicitly said in the lectures, but defined here. So yeah, do have a read and refer to your lecture notes as well. The final activity is on atmospheric transmittance. And really, this is probably one of the more applied type and what we'd encounter as researchers interested in understanding the radiation that comes up from the Earth's surface to a satellite in orbit, for example, and how we can use that information to infer things about the atmospheric conditions. So this is something a little bit close to my own area of research, which is why I've included it, and that's looking at real satellite data and understanding that parts of the electromagnetic spectrum don't make it from the Earth to the top of the atmosphere. And you should understand why that is, absorption of the various gases, and try to understand then how can we get a picture like what I've got displayed here now from that information. So hopefully that's sufficient information to get going. Of course, we'll see you on Thursday to go through this, but all the best. Remember, there's resources online, lecture notes. These Should have enough stuff in the questions as well to help, but also do Google. Okay, good luck, and I'll see you soon.